in 4.6.3, the related Sage code. Let's go through the code. Reset. Looks like I'm defining 4 variables, A, B, C, and X. I'm going to type this in a little bit differently than I normally do. I'm just going to quote all 4 together. All right. I'm still defining them individually though. All right. So there's variables A, B, C, and X now. All right. Next thing I'm going to say assume. I'm going to assume that A is greater than 1. I'm going to assume that B is greater than 1. I'm going to assume that C is greater than 1. I'm going to assume that X is greater than 1. I'm going to define an equation now, so I'm assigning EQ1. The name is arbitrary. You can call it whatever you want, like Bob or Sally. I think equation 1 is more appropriate, though. Equals, that means it's assigned. I shouldn't say equal, it's assigned. The equation, A times B, double equal signs indicate an equation, X to the 1/9 power. All right, I'm going to assign equation 2 now, EQ2. It's going to be assigned B times C, B star C. By the way, I want to point out if I put BC down, I'm going to show you what happens. Because some people say, oh, BC is B times C. Well, in algebra it is, but X to the 1/18th, right? And you see what happens here. It says there's an error. So I'm just going to say that if you're getting an error, certainly you can read the error message. It says that BC is not defined. It's not defined. So I'm going to correct it by putting B star C. Both B and C are defined variables, by the way. Let's put down equation 3, EQ3. This is being assigned A times B times C. And that is equal to X to the 1/8 power now. All right, I'm going to say solve. And I'm going to solve. There's 3 equations now. Equation 1, EQ1, it's a list. EQ2 and EQ3. And I'm going to solve that for a triplet now, A, B, and C. And let's see how it does. Whoops. All right, I got it. All right. So it tells me what A is, it tells me what B is, it tells me what C is. All right. I'm going to say S now. I'm assigning S to the prior output. And you've certainly seen me do this before. All right. So S now has been assigned that prior output. So if I display S, I'd get this over here. Again, I know this seems strange to you, but it's really a list within a list. So if I do S0, watch what happens. I get that list within the list. Now if I do S0, 0, I should get the first entry in that internal list, which would be A equals, right? I get it there. Now if I do this over here, dot right hand side of that entry, I should get X to the 5/72. If I do left hand side, I would get A. All right. So I hope you realize we're getting values here, and we're also looking at left side, right side. So let's take a look and see what they want me to do. So what I'm going to type down is I'm typing what I'm seeing now in the notes. By the way, I'm no longer talking through it. It's 0, 0. Right hand side. We just did that before. No different there. I know what that's going to give me. It gives me this over here. And now I'm going to do multiply it by, let me put this down, S, let's see, 0. But now I want the third entry. I want the third entry, left-hand side. I'm sorry, right-hand side. What am I saying? And what do you get? X to the 1/12. Let's go back over the notes, though. And the point of this is that you realize that you're just getting your feet wet, I say, with coding. And I want to look back over the notes, by the way. And I think we did this problem. It's problem number 3. All right, we did that problem number 3. And I went through it and we got an answer. And I guess the question over here is, yeah, what's the log base AC of x? It's, let's see if I did that. 1/12 of x. AC, I just did AC, right? Is x to the 1/12. Let me see what I said over here and see what's the difference here. They want log base AC of x. X to x is, let's take a look. I gotta be careful here. C to the 12th would be equal to x. And let's see. AC to the 12th is equal to x. AC to the 12th is equal to x, right? Yeah, that's fine. All right, we did all right. Thank you for paying attention. Again, I had to think about that for a second. Sometimes I